A machine stands silently on a factory floor. It doesn't spin, it doesn't cut, it doesn't move at incredible speed. Yet within seconds, it can flatten solid steel, shatter hardened components, and generate forces so immense that even industrial machinery struggles to withstand them. The hydraulic press is one of the most powerful machines ever built. Some industrial models produce thousands of tons of force, enough to reshape massive metal parts that would otherwise resist every attempt at manipulation. But what actually happens inside this machine when that force is unleashed? Today, we're going deep inside the world of hydraulic press crushing. From the hidden science of fluid power to the incredible engineering that allows steel to bend like clay, we'll uncover how crushing machines transform raw force into one of manufacturing's most valuable industrial tools. The hydraulic press is one of the foundational technologies of modern industry. While many people recognize hydraulic press crushing videos for their satisfying destruction, the real story is far more fascinating. These machines play critical roles in automotive manufacturing, aerospace production, heavy equipment fabrication, recycling operations, and countless industrial sectors around the world. At its core, a hydraulic press converts fluid pressure into enormous mechanical force. Unlike impact-based systems that rely on speed, hydraulic presses rely on controlled power. This allows engineers to precisely shape, compress, test, and crush materials with remarkable accuracy. In this documentary, we'll explore how industrial hydraulic press systems are designed, how crushing machines generate immense force, how automation controls every movement, and why hydraulic press technology remains essential to global manufacturing. The story begins with a simple scientific principle discovered centuries ago. When pressure is applied to a confined fluid, that pressure spreads equally throughout the entire system. This concept, known as Pascal's law, forms the foundation of every hydraulic press operating today. Inside an industrial hydraulic press, powerful pumps force hydraulic oil through a network of valves, pipes, and cylinders. As pressure builds, the fluid pushes against a piston. Because the piston has a much larger surface area than the pump mechanism that created the pressure, force is multiplied dramatically. This multiplication effect allows relatively compact hydraulic systems to generate extraordinary crushing power. Some industrial presses operate at pressures exceeding 5,000 pounds per square inch. Combined with massive cylinder diameters, the resulting force can reach thousands of tons. But generating force is only part of the challenge. Engineers must also maintain precise control. A hydraulic press moving only a few millimeters too far could destroy expensive components or damage tooling worth hundreds of thousands of dollars. This balance between overwhelming force and microscopic precision is what makes hydraulic press engineering so remarkable. At first glance, a hydraulic press appears deceptively simple. A large steel frame supports an upper ram and a lower work surface. But hidden inside the structure is an intricate network of engineering systems working together simultaneously. Massive hydraulic cylinders serve as the machine's muscles. High-capacity pumps continuously circulate hydraulic fluid. Electronic sensors monitor pressure, position, temperature, and flow rates in real time. Industrial crushing machines often include programmable logic controllers that process thousands of data points every second. When an operator initiates a crushing cycle, the control system begins a carefully calculated sequence. Valves open with millisecond precision. Hydraulic fluid rushes toward the cylinders. The ram descends steadily toward the target material. As contact occurs, sensors immediately detect resistance changes. The machine continuously adjusts pressure delivery to maintain optimal force distribution. This dynamic response allows industrial hydraulic presses to crush materials ranging from soft aluminum to hardened alloy steel while maintaining exceptional accuracy. Yet one question remains: what actually happens to a material when thousands of tons of force begin compressing it? The crushing process is far more complex than simple destruction. Every material responds differently when exposed to extreme compression. Soft metals initially deform elastically, meaning they temporarily change shape before returning to normal dimensions if pressure is removed. As force increases, the material reaches its yield point. Beyond this threshold, permanent deformation begins. Crystal structures inside the metal shift. Molecular bonds rearrange. Internal stresses redistribute throughout the object. Under a hydraulic press, these microscopic changes quickly become visible. Steel bars bend, machine components collapse, cast parts fracture along hidden stress lines. In some cases, crushing reveals manufacturing defects invisible to the naked eye. Engineers often use hydraulic press testing specifically to identify weaknesses before products enter service. The most fascinating aspect is how predictable the process becomes. Using computer simulations, manufacturers can often forecast exactly how a component will deform before it ever reaches the press. This predictive capability saves millions of dollars in development costs while improving product reliability. Modern crushing machines are no longer controlled solely by human operators. Advanced automation systems now oversee nearly every stage of operation. Laser position sensors continuously track ram movement. Pressure transducers monitor hydraulic performance. Thermal sensors protect critical components from overheating. Industrial control software integrates all these inputs into a centralized monitoring platform. If a pressure spike occurs, corrective actions happen automatically. If hydraulic temperatures rise above acceptable levels, cooling systems activate instantly. Some facilities even use artificial intelligence algorithms to optimize pressing cycles. By analyzing historical performance data, these systems identify efficiency improvements that human operators might never detect. The result is higher productivity, lower energy consumption, and greater equipment longevity. In large manufacturing facilities, a single operator may supervise multiple hydraulic press systems simultaneously. This transformation illustrates how industrial automation continues reshaping heavy manufacturing worldwide. Applying immense force creates unique quality challenges. Every crushing cycle must deliver consistent results. Even minor variations can affect product performance. To achieve this consistency, manufacturers employ rigorous quality control procedures. Before production begins, calibration specialists verify sensor accuracy. Hydraulic pressures are tested repeatedly. Cylinder movement is measured to fractions of a millimeter. During operation, advanced monitoring systems record every cycle. Force curves, displacement data, temperature readings, and timing information are stored for analysis. If abnormalities appear, engineers can trace the issue back to a specific production cycle. Some industries demand even greater precision. Aerospace manufacturers may inspect pressed components using ultrasonic scanning systems capable of detecting microscopic internal defects. Automotive suppliers often perform destructive testing on sample parts to validate production quality. These procedures ensure that hydraulic press operations meet strict performance standards while minimizing risk. Hydraulic press crushing extends far beyond dramatic demonstrations. In automotive manufacturing, presses shape body panels, suspension components, and structural reinforcements. In aerospace facilities, they form high-strength alloys used in aircraft structures. In recycling plants, crushing machines compress scrap metal into dense blocks for transportation and reprocessing. Without hydraulic press technology, many modern supply chains would become dramatically less efficient. The economic impact is enormous. Compressed scrap metal reduces transportation costs, precision-formed components improve production efficiency. Automated pressing operations lower labor requirements while increasing throughput. For manufacturers competing in global markets, hydraulic press systems provide a crucial advantage. The ability to process materials faster, more accurately, and more consistently directly affects profitability. And as industries continue demanding stronger materials and tighter tolerances, hydraulic presses become even more valuable. The next generation of hydraulic press systems is already emerging. Digital twins now allow engineers to simulate entire crushing operations before physical production begins. Smart sensors continuously analyze machine health. Predictive maintenance software identifies wear patterns before failures occur. Energy-efficient hydraulic systems reduce power consumption while maintaining force output. Researchers are also exploring hybrid systems that combine hydraulic power with advanced electric drive technologies. These innovations promise greater precision, improved sustainability, and lower operating costs. As manufacturing evolves toward Industry 4.0, hydraulic presses are becoming intelligent machines capable of self-monitoring and self-optimization. What began as a simple application of fluid pressure is transforming into one of the most advanced technologies on the factory floor. The hydraulic press represents a remarkable combination of science, engineering, and industrial power. From shaping aircraft components to recycling thousands of tons of metal, these crushing machines perform tasks that few other technologies can achieve. Every crushing cycle demonstrates the incredible potential of hydraulic force. Behind every movement lies decades of engineering innovation, precision control systems, and advanced manufacturing expertise. As industries continue pushing the limits of material science and production efficiency, the hydraulic press will remain one of the most important machines ever built. If you enjoyed this deep dive into hydraulic press crushing technology, be sure to subscribe to Machines Hub for more fascinating journeys inside the world's most powerful factories, machines, and engineering systems.